Kia ora, everyone. Wow, what an incredible room. I just want to say just what a privilege it is to be on stage in such an incredible venue. Tākina is very special. I really want to acknowledge the mana whenua of the tāngata whenua here in Whananui Tara, tēnā koutou. It's truly a privilege to be up here and talking to you today. Nō reira, kia ora koutou, ko Daniel Larsen tōku ingoa, no tāmaki makaurau aho. My name's Daniel, I live in Auckland in New Zealand. And as Greg said, I used to work for Microsoft with Will, who's just sat over there, my good friend Will. And until recently now I'm an independent consultant talking about cloud and working with companies. One of those companies that I'm working with at the moment is called Plexure. They're an amazing cloud native SaaS company based in Auckland. And I'm currently working with them on resiliency. So resiliency within Azure. So I used to work for Azure Engineering on the Azure Engineering team with Fast Track, if you know those guys. And we're also working on helping that business to get to the next order of magnitude, which is kind of my sweet spot. That's what I love doing and talking to companies about. Can I see a show of hands? Who would consider themselves to be cloud native? And this is a trick question, so anyone can put their hands up. I'm not going to growl at you. Any cloud native businesses in the room? Yeah, it's funny, eh? It's such a difficult term to define. I still haven't figured out what cloud native actually means. But I think if you're heading towards cloud or you're in the cloud, that's a pretty good start. What about software as a service? Who's doing software as a service? Awesome. And keep your hands up if you would consider yourself B2C. So you're a consumer business software as a service. Cool. What about B2B? Any B2B friends here? Yeah, awesome. Okay. So my talk today is going to be about about strategies for cloud native SaaS businesses to scale. Okay, the numbers I'm going to be talking about are very much B2C, but of course you can translate any of this to B2B, or even if you feel that you're more enterprise, not really a SaaS company, it's fine. All of this stuff are really ideas that I've collected in my journeys along the way, either working for companies or with companies who are on that road. They want to get bigger. Now I know it's you had lunch a little while ago. It's what is it? Almost 2 o'clock. This is usually the time where we go to Do Not Disturb on Teams, right? Yeah, it's all right. There's no shame. I got 3 kids. I know what it's like. It's that time of the day. So I'm just going to rev you up a little bit with a Department of Statistics slide. This should get us going. This is exports. There's nothing like an exports graph to start a talk, but I really wanted to bring in some business context into this discussion. This is ICT exports, and it's actually only part of them according to the TIN 200 report that highlights that technology is actually our second largest exporter after dairy now, which is fantastic. But the important thing here is the growth. What we're seeing here is between 5% and 9% growth year on year for the last 4 years, which is great, right? Anyone would be happy with that growth. But the reality is that technology companies, that's all of you here in this room, you are growing 9 times faster than the New Zealand economy. Now that's super interesting. That's awesome news. We want to grow. That's a good thing. But the other thing is we have to keep up with that growth, right? That's a bit of a challenge to us that we have to keep on growing. So how do we keep on doing that? Because sooner or later we're going to hit a point where we're going to have to start thinking about that next order of magnitude. Now, there are some great business strategists in the room. I was talking to Gareth earlier, who's one of them. I'm a technology person, I'm an architect. When I hear growth, I hear scale. And what I'm here to talk to you about is more scale. So let's get into some of the architectural challenges around that. And first of all, a quote from one of my favorite architects and CTOs, and that's Werner Vogels, who said that, and I'm going to give you the full quote here, I have to read it. It's, "My rule of thumb has been that with every order of magnitude of growth, you should revisit your architecture." But he doesn't stop there. He says, "and determine whether it can still support the next order level of growth." Now that is actually really profound. It's not just about looking at our architecture and going, yeah, okay, it looks pretty good. It's actually going, well, what would we do if we had to go 10x next week, next month, next year, next 3 years? What would that actually look like to us now? And architects that I'm working with and that I really admire always got that one eye on the future. What is that next order or level of growth? What are we actually talking about here? Let's plot that on a simple vertical arrow to see what orders of magnitude looks like. This is very simple. We've gone from hundreds to thousands to tens of thousands to 100,000 and so on. If you are one of those B2C SaaS companies, plot your number of users on this chart and have a look at what is that next order of magnitude. You know, so if you're currently doing, say, millions and you want to get to tens of millions, then how would you re-architect to get there? That's a great challenging question. It's a good one to stand around the whiteboard with your architecture friends and discuss. If you're lucky enough to be growing, let's say at 50% annually, and I know SaaS businesses are growing at that rate, then 10x your current 10x your current order of magnitude. So 10x your current numbers is actually only 6 years away. So that's if you're growing at 50% year on year, 10x is only 6 years away. Cool, 6 years. But what if your architecture is 5 years old? You may only have 1 year of effective life left on that architecture. Sooner or later, you're going to have to say, well, we're going to have to start re-looking at this architecture and seeing what we can do to get that. Regardless of how fast or how slow that you are growing, the time to plan for scale to meet growth is right now. It's such an architectural cliche, Conway's law. I always roll my eyes when speakers put up this slide, but I'm going to do it to you today because there's a couple of really important things that I want to point out about Conway's law. First of all, I'll read the quote. It's that systems will mimic the communication structures of the organizations that design them. The reason why I want to put this up is because I want to talk about service-oriented architectures next and how they change as a business grows. So there's two things that I find really interesting about Conway's law. The first one that I want to talk about is it's called a law for a reason. It's very, very seldom that you will see this not be true. The communication structures of an organization will always the systems that will always mimic those communication structures. And furthermore, they will adapt with the organization as it grows. And you can see that. You can see that over time. I'm going to show you a demonstration of that. And just keep that in mind as we look at these next few slides. The other interesting aspect of Conway's law is that it can also work in reverse. So introducing systems that improve communications structures will often drive organizational change. So if you can, cast your mind back to before we put in Slack or Teams into our organizations and think about how we used to communicate with each other. Like, how did that even work? And what has that actually done for cross-team collaboration and breaking down some of those silos? Yesterday, Natalia, I'm not sure if Natalia is here, but did an excellent talk at the pre-conference last night about Azure DevOps. Azure DevOps is another great example of bringing together teams into one sort of cohesive, I hate to call it DevOps, but you know, platform for looking at DevOps and planning and all the other aspects of that. The other great example is GitHub. You know, how did we even collaborate on source code before GitHub came along? You know, can anyone remember what we did before then? Was it just, you know, zip files and cross your fingers? So, yeah, I think those things are really interesting about that. Anyway, let's get back to service-oriented architecture and behold the monolith. Now, the monolith, it's an oldie, but it's a goodie, and it's certainly not dead. We still see loads of monoliths in production, even at scale. There's a lot of organizations that are working with monoliths. Another great Werner Vogel's blog post just recently was titled "The Monolith is Not Dead." It's a lot of startup architectures will start out this way. So starting from the top, let's just walk you through it. I don't know if my cool little laser pointer works. No, but from the top there, we've got we've got mobile and desktop clients, and they're talking to an endpoint which is receiving all of the requests from those clients into a web service which is talking to a relational database, right? Fairly simple. All of the communication is synchronous and nothing is distributed in this architecture, right? All our repos and our releases are monolithic, and all code lives in the same place and everything is all deployed at once. Now you can see why this architecture is so popular with startups, because it mimics a small organization structure, right? Everyone's in the same room, they're all talking to each other. It's the classic two-pizza team. Okay, so that's the monolith. Let's go up in order, or to API services. As the business grows, there's more work to do. More people are employed. It gets harder for all those people to work on the same thing. So we start adding these separate API services out on the side that can be developed independently. And they start building out an API facade, which is that horizontal line you can see there, with multiple endpoints now for clients to consume and innovate on. But notice that this architecture is still monolithic. All of those services are still talking to the same data layer. There's probably a lot of tight coupling in that database layer. There's probably a lot of spaghetti code going on there and that sort of thing. But we're starting to see a bit of growth. Uh-oh, wrong button. Oh, sorry. Cool. At this order of magnitude, this is more of a domain services architecture, the business is really starting to boom. User growth is high, the engineering organization is growing, it has outgrown command and control. What that means is teams are no longer prepared to wait for someone to come in and tell them what to do. They don't want to wait for an architect like me to come in and say, yep, it's okay to do that. They just want to do it. They want to be autonomous. So we're starting to see autonomous teams that are built around domain teams. Pradeep's called this out absolutely beautifully, where we have domain teams who want to work on these things. It's domain-driven design, really comes from that amazing Eric Evans book. And the reason why they want to be autonomous is because they want to move faster. They just don't want to stick around being told what to do anymore. In this architecture, the monolith is still there, right? Still there in the middle, but nothing else is talking to it. It's gradually being strangled out, and new domain services have been added on the side. And notice that they have their own databases. So they're starting to have their own data storage, where they're storing data that's important to them. Now we're seeing asynchronous inter-service communication via that high-speed bus. This allows us to decouple our services. This allows these services to release independently if they want to. We're starting to see some good distributed patterns coming in here. We're probably at this stage, we're starting to consider what earlier talks have talked about, and that is having a platform team. So a platform team might be starting to operate our infrastructure, because to operate these services, to provide a network and storage and the products, the network and storage services and compute services that these product domain services are relying on. Cool. At this level of magnitude, at this order of magnitude, the system and its products are maturing fast. Intense customer demand is driving way more features than a single two-pizza team can handle. What's interesting here is it's not just the users that are driving this growth. I'm proposing that it's actually the organization that's driving the growth of these microservices, because what's happening is that the domain services are now getting too big for a two-pizza team. We're adding more and more features on, which means we now to logically subdivide these domain services down into microservices. An AWS storage service may have hundreds of microservices that are serving, what is a fairly straightforward API. So it's definitely a thing. And the monolith has been completely strangled in this diagram. There is no monolith anymore. It just would not work at this scale. Distributed computing practices are coming to the fore. We can see loose coupling. We can see eventual consistency everywhere. We're starting to talk about big data and those types of pipelines as well. At hyperscale, this looks like hundreds of autonomous teams all releasing on their own release timeline, which is interesting. How on earth did they do that? We're going to talk about that later. And it's beautiful. It's a very interesting pattern, and we see this in the hyperscalers like AWS, Google, and Microsoft for sure. But I want you to consider something right now, and that is this the operating model you would choose for your organization now? Because some vendors will often tout their largest customer architectures. And I would say the Netflix architecture or the Xbox architecture may not be the right architecture for you right now, right? It's perfect for Netflix and perfect for Xbox, apparently, for them. But there's no doubt that they've had to revisit and re-architect many times in the 15 plus years that they've been working. So it's really important to look at your current organization, your current growth, and choose the right architecture for you. So if you're currently sweating a monolith, that's okay. I've got plenty of customers. I know lots of organizations that are doing that. If you started your journey on microservices, that's also okay. It's fine. As long as your architects have always got one eye on the future and they're starting to always keep an eye on that next order of magnitude. I love continuums. This is my last continuum slide, so I'm just going to put it up here. I've just put some compute choices along the top. They are vendor specific, I'm sorry, but on the left-hand side, we've got Azure App Services. If you know Azure App Services or Google App Engine, they're fully managed app services. You can chuck an ASP.NET website or a PHP website up there and it'll just run it. That's great. Contrast that with Azure Container Apps, which is sort of a slightly more managed container app service, and then we've got the managed Kubernetes products, AKS, EKS, Azure Red Hat OpenShift, or Red Hat OpenShift, I should say. Those types of services are doing a really good job with managed Kubernetes. And on the far end of the scale, we've got VM scale sets, which is at a very extreme end of the scale, some services are building their products on. We're not going to go there today, but that's definitely a thing. And I've plotted those alongside scale, so scale of services actually, from 1 to hundreds, and then brought in these other considerations. So it's purely conceptual, obviously. It's not to scale. I just want to put this up here to reason about these types of trade-offs. So it is possible to run tens of services on an app service, the fully managed platform, but it's very difficult to run hundreds. It would be almost impossible. And some teams will just run a handful of services on Kubernetes, right? Like, it's fine, it works great. However, before leaping into a new compute choice, it's important to consider some of these factors. For example, when you get to having more than 20 services, you will likely need an orchestrator and a service mesh and lots of other things. They're not really found in a managed hosting platform like app services. That's not to say app services won't scale to tens of millions of users. I know customers who are doing that, but it's not ideal for that. The good thing about a fully managed service is that it frees up engineering effort to concentrate on product development. But the flip side of that is that as you grow, it can become very frustrating for teams who want to have control and they want to have observability of those platforms because they're fairly opaque. Contrast that with managed Kubernetes services, on the other hand. They're ideal for hosting tens or hundreds of services in highly available clusters at scale. However, our complexity goes up, and a dedicated platform ops team is almost certainly going to be required to keep that platform highly available and secure. And there are interesting cost optimization trade-offs here as well. For those teams who are sort of erring towards the right-hand side of that view, those services up there, they usually have the ability to be able to pack a lot more density. So a lot more, if they were measuring cost to serve by user, they would be doing a lot more on the right-hand end of that scale. However, the trade-off there we have to make, obviously, is the engineering effort. The total cost of ownership of those services needs to be weighed up as well, so it's not always that straightforward. Cool. So that's a few slides on the continuums and what changes as things scale. I want to leave you now with just, in my last few minutes, a few hints in terms of making a plan. Okay, I've told you should be considering the next order of magnitude and keeping an eye on the future. How do we actually do that? How do I actually do it? Well, next concept I want to remind you of is out of a brilliant book by Eric Ries. I'm sure a lot of you have read it. It's called The Lean Startup. And Eric does, I think, one of the best jobs of explaining where strategy fits in an overall organization. And it starts at the bottom. So what Eric is saying is that product builds on strategy, which builds on vision. If we have a really clear vision in the organization and it's well communicated, it really defines the where and the why. You know, where are we going and why? And that middle layer is strategy, and there are multiple strategies in an organization. I'm talking about tech strategy, but you'll also have sales and product strategy at that layer as well, and they should be all collaborating and considering one another. Now, the products now are now able to build on that vision and that strategy to produce great products, and we see this time and time again through history. This really works well. I'm going to give you some concrete examples here. So I'm going to start up an AI chatbot company. It's got a nice clear vision. It is to empower every person on the planet with a truly useful AI personal assistant. Wouldn't that be amazing? My strategy for that, and this is just technology strategy, we're not talking about product strategy just yet, is to reduce the time to market by building on third-party AI APIs. So I might be choosing, at the product level, when the product team are going to build that service, I might be choosing an open AI service from Microsoft or Google, for example. Okay, just one more example, just to really reinforce this point. To help affect this vision, I might say that I want to improve developer productivity with AI code tools. Michelle's going to talk about GitHub Copilot this afternoon. That might be what our teams go and reach for to help to improve their developer productivity. Again, no product strategy in here at the moment, but obviously that would be in there as well. And this model works in very big things like organizations. It also works in very small things like teams. If you want to build a vision, strategy, product strategy for teams, this works really well as well. Cool. So moving on back to this slide, focus there on the services that we've got on the bottom. Now we've got loads of services. I mentioned, very large companies like Facebook, they'll have hundreds of these services. I mentioned also that they'll be developed by their own teams. Those teams are quite autonomous, and they're all on their own release cycles. How do they do that, not completely trip each other out, and how's it not just complete chaos? Well, the answer is in the gaps you can see in between those services. So if you look closely at the boundaries around those microservices, those are boundaries. And if we hypothesize that a domain team is working after one of those services, now we're defining these contracts on the boundaries of those services. So I'm going to zoom into just one of those right now, right? So that's the blue box. I've zoomed into just one of those boxes. So let's say we've got a domain service team, as Pradeep talked about earlier today. It's a domain service team, but we're talking about on the product platform side. And what is that team responsible for? There's no right or wrong answer to this. You tell me what you do inside your organization. But the important thing is there's a boundary there. So to give you a few examples, this domain service team might be responsible for their repo, for writing code, obviously, for testing it, they may have an architect within their team. Obviously, they'll have product people involved in their team. They'll be managing their own backlog and so on, or not. You decide what's inside that box and what's outside. But whatever's outside, now we have contracts. We're crossing that boundary around that blue box, and now we need to have contracts between other service teams, between our first and third party customers, and also between our platform. We've talked a lot about platform today. At this scale, we definitely need a platform team. There are some contracts on those boundaries. To give you a couple of examples, a really easy one is the one that's poking out the top. Really good way to define our contract with our consumers, our clients who are calling our APIs, is with an open API spec using Swagger. On the bottom half there, we've got a platform team. The deal is, from the platform team, they say to us, look, if you ship us a tested and of quality package of software, we will deploy it into production for you. We will keep it secure. We'll keep it highly available, and we'll alert you when it's not running well. Okay, that might be an implicit contract with your platform team. If you wanted to get more explicit with that contract, then you might be looking at infrastructure as code. Infrastructure at that code layer is essentially that blue box declaring to the platform, this is what I require. I require this compute, this storage, those types of things, and infrastructure as code is a great way to declare that. And there are other examples as well. If you are sending events or messages or streams to other services or to your data platform, then you may have a contract class library to describe that as well. Contracts are fascinating. They're already there, even if you're only just doing a monolith. It's just, it's a great exercise to start calling them out and making them more explicit. Cool. Finally, this is purely conceptual. This is what I use to explain to SLT, to senior leadership teams, what we're doing and where we're going. I've put up a very rough example here of a roadmap. The great thing about a roadmap is it's employing something called improvement kata. Improvement kata means if we just start with one thing and then we move to that next target condition, even if we were only get to that target condition and stop there, we would still be bringing considerable value to our business. So in my proposal here, we're starting with a vision. The next step is to build out a strategy. The next step is to build out contracts. The next step is to build out IAC, infrastructure as code, sorry. If we stopped at infrastructure as code, that's still bringing tremendous value to the organization, even if we don't make it all the way to the top, which is our framework upgrade and our new compute platform. I love roadmaps for explaining these types of concepts to up and down the organization. So whether you're managing up or managing down, I find this really, really useful. Awesome. So in closing, Conway's Law explains why service-oriented architectures change as our organization grows. You don't have to use service-oriented service-oriented architecture in your organization. It's just a very useful lens to look at this type of behavior through. And when you can observe these effects, then you can start to plan for them. It makes it easier to reason with these, to have these conversations with your architecture team, not just architecture, but all engineering and product and the rest of the business as well. And technology strategy and contracts are a way to inform product teams what is important to the business. If you want to affect a technology into a team, start writing contracts. It's a negotiation, and get them involved in that process as well. Awesome. Thank you so much, everyone. It's such a privilege to be on stage with such an amazing lineup of speakers, and I hope you found some of that helpful. Enjoy the rest of your conference. Kia ora. Thank you.